Okay, we're at gotomath.com looking at some application problems involving linear equations. Alright, what do we got going on here? Nick, does anybody know Nick? 9.1. So Nick's an avid trout fisherman. He wants to know just how many trout are in this small lake, so he uses the capture, mark, and recapture technique. He nets 100 trout and marks all of them. After 7 days, he comes back and nets 100 trout and counts all of the trout that was marked and finds that only 10 of them have marks. How many trout are in the lake? So anyway, after doing some research on this problem, this is a real world problem, by the way, some things that need to be said about this problem, and that is, it says after 7 days. We have to consider that we're in a closed area and that no other new trout can come into the population and none can leave, and there's not any trout dying and things like that. So really, I guess the smaller this number is here, 7 days, 1 day, 2 days, probably the better off you're going to be, I guess. But anyway, let's get over to the whiteboard here. And another thing is, we're talking about trout here, but they do this in not just trout, but a lot of other different animals like squirrels and things of that nature. So, alright, but I was actually thinking, I could take this to the mall. They have this case with all these different colored balls. Let's put some different colors in here that are, and you might have seen this game before, but what it is they want your data. You fill out a little sheet here and guess how many balls are in here, and this thing is, right, we got air blowing in down from the bottom, okay, and blowing these balls around. But if you were able to capture a small portion of them, take a picture, count the number of balls, I'm thinking this ought to work. The same model should work for this, to figure out how many total number of balls are in the case blowing around. So that's, I guess, a different problem for a different day, but anyway, I don't know, I'm going to run a simulation on that and see how that works out. Anyway, so the way this works is, this proportion is actually the formula, and I'm just going to state the formula here. But the formula, so we're going to let T be like the total population, is actually equal to the total number captured. So we'll call this the total number captured times the number marked. So this would be the total, we'll say NM, whoops, this is the total number marked, and that's all over the total number captured with a mark. Total number captured with a mark. You see this? Okay. All right. So the ratio actually goes, you can rewrite this formula as the total, this is the total population, this is what you're trying to guess. And so we went out, and I guess we better use these numbers here, huh? Captured, recapture technique. He nets 100 trout. Okay, so we're going to put 100 down here. Alright, so this is the number that was captured right here. Right, the total number captured, and it should be equal to the total number marked. That would be this guy right here, and we actually marked 100 trout. So we captured 100 and we marked 100 and then we came back, right, captured another 100. We came back and found that only 10 of them had marks. Okay, so we captured 100, we marked them, released them into the we released all 100 into the population, came back some days later, captured 100, and found that only 10 of those had a mark. See that? Okay, and now we want to approximate what is the total population? So basically what we're doing here is just solving for T of P, right? This is what we're guessing the total population is. So that T we're calling total population, right? An estimation anyway. Solving for that, we get 100 times 100, which is 1,000. No, 100 times 100 is not 1,000. And then divide that by 10. But this is going to end up equaling, what is this going to end up equaling? 10 of them have marks, yeah. We got 10 goes in, see, 10 times, yeah, I guess its total is 1,000. I was thinking the answer was 1,000. I guess when I did 100 times 100. Yeah. So there's approximately 1,000 trout in the river. So this is an interesting model here. You might want to try that out on squirrels or something like that and see how many squirrels in a square foot area, like 2,000 square foot area, count them. I don't know how you're going to mark them, but good luck with trying to mark a wild squirrel. Anyway, so we're over here at gotomath.com, getting it worked out, and I'll see you in the next problem.